So you've made it to the end of week 2. Congratulations. You probably have something that looks sort of like this, can move a little bit, and then we've had a little conversation about how we want to present this thing. So in today's episode, we're going to kind of go under the hood and show you how I'm creating this stream here. It's also a way that you can perhaps do some video capture. I know in an initial post we talked about using the animation tool in Fusion, and the animation tool here is really good for making blown up displays. Things like where we could explode a given design here. Try to find one of these that'll actually work on this component, auto explode, and we could potentially get it so where you can see how this thing pulls apart or gets reassembled, as it were. That's sometimes useful, but for what we wanted for this activity, we kind of wanted this to be something where we'd see how something moved. And as you can see, we can just click and drag this. Nothing wrong with that. But if we want to see a full motion of this, the easiest way is to go into the Joints tab. And by the way, we can turn our joints on and off depending on if we want to see them or not, just by clicking the little eye there. And then we're going to go to one of our Revolute joints. Now in this case, I've kind of identified this joint here, and you can see it's one of the key joints here attached to the servo motor as the one that I want to animate. What I'm going to do here, actually I believe it's 43, it is 43. 43 is the one that's on my servo. Okay. We can name these, by the way, so if you do decide you want to name this as the servo drive, you can do that. It often helps in large complex, let's say a full FTC robot, to actually have those labeled so you can find out where all those joints are if you ever have to reference them in here. From here, I can actually right click on this, and among other things, including the joint limits like we did in the last video, I actually have the ability to animate this joint or animate this model. If I animate this joint, it's going to ignore anything that's grounded, so it's just going to spin the servo in place, which isn't really great. But if we press escape here to get ourselves back to normal, and then we right click on this and go animate model, it's going to actually give us a full animation of how this full model works. Now, the easiest way to send this to a mode where you can present to show how something works in our context is using a program called OBS. And I'm going to create a little bit of an infinity screen here by doing this, but this is OBS, and I'll leave the actual link to OBS in the description. It's a free broadcasting studio, and it's very simple. You just go down to your sources and choose your main display. In this case, I've gone to display capture, set up your main display or however many monitors you have, and actually just start your recording. At this point, it's going to save this as I believe an MKV file. You may want to go in and just change your settings here so that it actually exports as an MP4 if you feel more little closer, feel like MP4 is a little closer to your heart. It's not going to let me do that because I'm currently recording, but that tool is going to allow you to record this motion and maybe upload this so that all of your colleagues, as they are in this CAD challenge, can actually see something that you've built to push that button in Velocity Vortex. Now I want to show you one more thing, because we've got another version of this that's floating about here that I think is kind of cool. I'm just going to press escape and get onto that, and that's a Scissor Lift. Somebody actually asked about this, one of the SWAT bots or ATA people, asked about the idea of a scissor lift. Now I'm just going to warn everyone in robotics, this is a very basic scissor lift using non-standard parts. If any of you are considering this as part of one of your mechanisms, if you have access to a mill and you have some very specific accuracy with what you're trying to build, scissor lift is a really, really interesting thing to build. It's also very, very difficult to actually pull off. I'm just going to go ahead and animate this model, and you can see the whole thing move. It moves in a very interesting way when we do this. They can be very powerful, they can be very potent, but when they go wrong, scissor lifts go very wrong in robotics, and I don't recommend them to any new or even some of the moderately experienced FTC teams just because of those reliability issues. As soon as you're done on this, you can just hit stop recording in OBS and upload that file directly into the Google Drive folder. That works really well. I'm going to upload this one to YouTube, and we can look forward to seeing everybody for challenge number 3 next week. Cheers.